Okay, in this presentation we're going to look at another conditional probability question. So in this question we're looking at a manufacturing company that is analyzing its accident record. Now the accidents fall into two categories. So there are the minor accidents, which are dealt with by a first aider and they cost $50. And then there's the major ones that cost $1,000. They have to be dealt with by a hospital visit. So suppose the company has 1,000 employees, okay, that's important, of which 180 are office staff and the rest are work in the factory. Now, implicitly, we're told that that means that there are 820 working in the factory and 180 working in the office. You have to read these questions very carefully. Now, the analysis shows that 10% of employees have an accident each year, okay, and 20% of these accidents are major. So it's assumed that an employee has no more than one accident a year, just for the sake of simplicity, making this question tractable. So determine the expected total cost of accidents in a year. Okay. And okay, so that's the first question. So this actually follows the rest of it. There is related to question B. So the first question is determine the expected total cost of accidents in a year. So for the rest of it, we'd sort of like question parts B and C. On further analysis, it is discovered that a member of office staff has half the probability of having an accident relative to those in the factory. So that's information we'll use in part B. Okay, I'll tell you what, we'll actually just go up to part A because it's quite a long one and we'll come back to part B. So the first thing we do is sort of set out our notation for events. So the A is the probability that a person has had an accident. O is that the person is office staff, and F is that the person works in the factory. Now these are complementary events, okay? And we're sort of assuming that these two events describe all of the people in the factory, such that they're either office staff or factory staff, and that they are complements. Okay, so the expected total cost of an accident. So we have major accidents and minor accidents. Okay, so the average cost of a major accident times the probability of a major given that it was an accident, and minor given that it was given times the probability. So essentially we're looking at the cost here. Okay, so we were told previously that 20% of the accidents were major and 80% were minor, and that the cost was 1,000 for a major accident, okay, so, and 50 for a minor accident, okay, so that essentially that's 200 plus 40, which means that the average cost of an accident is $240, okay. So the expected total cost of accidents is, how many employees do we have? We have 1,000 employees, okay. On an average, there's a 10% probability that they will have an accident, so that's the probability of an accident. So out of 1,000 people, we expect 100 to have an accident in any given year, okay. And so if there's 100 accidents in a year and the average cost of an accident is 240, that means that the expected total cost of accidents in a workplace is $24,000. Okay, so that's the first part done. Now, what we were told previously is that the office staff are half as likely to have accidents as the factory floor staff. Okay, and that's how we would express it there. Okay, probability of A given A given O, which is the accident given that you're office staff, is half of the probability of having an accident given that you're factory staff. So that's what we're told. Now we're just going to rearrange it. We can rearrange it arithmetically such that we have that expression there instead. So one or the other, I'm actually going to use the second one. Now, we were told actually in the question at the start, we were given quite a lot of information. For example, probability of an accident is 10%, office staff is 18%, and factory floor staff is 82%. So that's all the useful pieces of information we were given. Okay. Now we're going to use the total law of probability. Now usually what we're asked to do is find this, but actually we have the answer there up above. So what we have to do here is what we're going to do is express this as the probability of having an accident and being office staff plus the probability of having an accident and being factory floor staff. This is the total probability law. Okay, essentially you could split up an event into component parts if you're able to account for each possible scenario. And here the scenarios are office or factory floor. So using the conditional probability formula, we can express that as that, and that expression there, probability of A and F, as the probability A given F times the probability of F. That is conditional probability, the conditional probability formula just applied there. Okay. Now, so this is where it gets interesting. We don't really have an expression for either of these two terms. Okay, we just know that one is twice the other. So the probability of A given 0, sorry, A given O, I keep saying 0, A given O is twice the probability of A given F. Sorry, half of it. So that means probability of A given F can be written as 2 times the probability of A given O. Okay, so essentially what I'm going to do here is substitute that with that. So we have one less expression to worry about. And remember, we do know what probability of A is. It is 0.1. So what we're going to do here is, essentially what we can do is, this expression here, okay, what we can do with that is just tidy it up such that we have probability of A given O times 1.82, and that is equal to 0.1, okay. And working that out, we would find that the probability of A given O is 0.1 divided by 1.82, which is 0.0549, so 5.5%. Let's just scroll up there because I didn't actually read out the question that we were asked. Show that the probability that a given staff member of office staff has an accident, show that the probability of that is 0.0549. So that's what we've done. That is part B done there. Okay. So determine the probability. So we're on part C now. Okay. Determine the probability that a randomly chosen employee who has an accident is office staff. Now always be careful reading these questions. Now you can sort of tell that it is a conditional probability, but it's a sort of case of what given what. Is it A given O or O given A? Well, it's actually that we know they've had an accident, okay? So what's the probability that they're office staff? That's what we're looking for, okay? So we know that they are office staff, so we're interested in finding out if they, so we know that they've had an accident. We want to know if they are office staff. So that's what we do there. Probability of O given A, and that is, I'm sort of skipping a bit there, but essentially that's O and A all over the probability of A. Okay, and using the conditional probability formula again, I can express probability of O and A as probability A given O times the probability of O all over the probability of A. Okay, so we know each of these three terms now here. We know that probability of O is 18%. We know that the probability of having an accident is 0.1, and also in the last part we found out that the probability of A given O is 0.0549. So working that all out with a calculator, we should get an answer of 0.099, and that is the answer we're looking for there, for that last part there, part C. Okay, we'll leave it there.